Hey there, science fans! Today, we're diving into the exciting world of electronics. Just like building a house requires bricks, cement, and lumber, electronic circuits rely on essential components. These components, called resistors, inductors, and capacitors, are the fundamental building blocks of countless electronic devices we use every day. Think about your smartphone, computer, or even your trusty toaster oven. They all rely on the precise interplay of these components. They might seem small and unassuming, but understanding how they work unlocks the secrets behind the magic of modern electronics. In this exploration, we'll unravel the mysteries of resistors, inductors, and capacitors. We'll discover what they are, how they function individually, and how they work together to shape the flow of electricity. Get ready to unlock the fascinating world of electronics. Let's start with resistors, the traffic controllers of the electrical world. Imagine electricity flowing like water through a pipe. A resistor acts like a narrow section in the pipe, resisting the flow of water. This resistance is intentional and crucial in electronics. Resistors limit the amount of electrical current passing through them. This control is essential to protect sensitive components, divide voltages, and fine-tune circuit behavior. The amount of resistance a resistor offers is measured in ohms, omega. A higher ohm value means more resistance, just like a narrower pipe restricts water flow more. Resistors come in various shapes, sizes, and resistance values, allowing engineers to precisely control current flow in their circuits. Resistors are everywhere in our electronic devices, quietly working behind the scenes. Remember the volume knob on your radio or headphones? That's a variable resistor in action. Turning the knob changes the resistance, which in turn adjusts the amount of current flowing to the speakers, making the sound louder or softer. Similarly, the dimmer switch for your lights uses a variable resistor to control the brightness by altering the current flowing to the bulb. Resistors are also crucial in protecting sensitive components. Imagine a surge of electricity, like a sudden rush of water in our pipe analogy. A resistor can act as a safety valve, limiting the current and preventing damage to delicate electronic parts. Next, let's explore inductors, the energy storage experts of the electronics world. Think of an inductor like a coiled spring. When you compress a spring, you store potential energy. Similarly, an inductor stores energy in a magnetic field when an electrical current flows through it. An inductor is essentially a coil of wire, sometimes wrapped around a core of magnetic material like iron. When electricity flows through the coil, it creates a magnetic field around it. What's fascinating is that this magnetic field resists changes in current flow. It's like the inductor has inertia when it comes to changes in current. The unit of inductance is the Henry, H, named after the American scientist Joseph Henry. A larger inductance means the inductor can store more energy in its magnetic field. Section 5. Inductors at work, from speakers to power supplies. Inductors are essential in various electronic devices, especially those dealing with fluctuating currents. Have you ever wondered how speakers transform electrical signals into audible sound waves? It's inductors at play. Inside a speaker, a coil of wire, or the inductor, sits within a magnetic field. As the electrical signal representing the audio fluctuates, it changes the current flowing through the coil. This in turn creates varying magnetic fields that interact with the permanent magnet, causing the speaker cone to vibrate and produce sound. Inductors are also critical in power supplies, where they help smooth out the flow of electricity, ensuring your devices receive a steady and reliable current. Section 6. Capacitors, holding an electrical charge. Now let's meet capacitors, the charge-storing wizards of electronics. Imagine a capacitor like a water tower. Just as a water tower stores water for future use, a capacitor stores electrical charge. A capacitor consists of two conductive plates separated by an insulating material called a dielectric. When connected to a voltage source, one plate accumulates positive charge while the other accumulates an equal amount of negative charge. This separation of charge creates an electric field between the plates, storing electrical energy. The capacity of a capacitor to store charge is measured in farads. A larger capacitance means the capacitor can store more charge, just like a larger water tower can hold more water. Section 7. Capacitors in our lives, from touchscreens to flash photography. Capacitors are ubiquitous in modern electronics, playing vital roles in various applications. Ever wondered how your smartphone's touchscreen registers your touch? It's capacitors at work. Touchscreens often use a grid of tiny capacitors. When your finger touches the screen, it changes the capacitance at that point, which the device detects and interprets as a touch input. Similarly, capacitors are essential in flash photography. Remember those disposable cameras with bright flashes? They use a capacitor to store a large charge, which is then rapidly discharged to power the flash bulb, illuminating your subject in a burst of light. Section 8. Why these components matter. The importance of RLC circuits. Resistors, inductors, and capacitors are often used together in circuits called RLC circuits, forming the backbone of many electronic systems. These circuits, named after the initials of their constituent components, exhibit fascinating behaviors due to the interplay of resistance, inductance, and capacitance. RLC circuits can be designed to filter specific frequencies, allowing only desired signals to pass through while attenuating others. This selective filtering is crucial in radios, TVs, and wireless communication systems, where it helps isolate the desired signals from a sea of electromagnetic waves. Furthermore, RLC circuits can resonate at specific frequencies, like a swing set finding its natural rhythm. This resonant behavior is exploited in oscillators, which generate precise frequencies used in clocks, microprocessors, and countless other electronic devices. Section 9. Conclusion. Wrapping it up. Today we've journeyed into the fascinating world of electronics and explored the fundamental building blocks, resistors, inductors, and capacitors. We've learned that resistors control current flow, inductors store energy in magnetic fields, and capacitors store electrical charge. These seemingly simple components, working individually or in concert as RLC circuits, form the backbone of countless electronic devices we rely on daily. From controlling volume to storing energy and filtering signals, resistors, inductors, and capacitors truly are the unsung heroes of the electronic age. So next time you use your smartphone, listen to music, or even turn on a light, take a moment to appreciate the intricate dance of electrons, orchestrated by these tiny yet mighty components. Their importance in shaping our technological world cannot be overstated. Keep exploring, keep questioning, and keep the spirit of scientific discovery alive.